here to tell you about the different kinds of ways to view a 3D movie. First way I'm going to tell you about is the eclipse method. Eclipse method, you have a mechanical side glasses and two images are projected onto the screen, but each projector flips on and off. So at one point in time, only one of the images is projected on the screen, and your glasses go with that, and it'll close a shutter on either side of the eyes, depending on which image is up on the screen at a time, so you have a constant change of images you're seeing, which projects the 3D image. And the next one we have is a lenticular. Basically, this one doesn't need glasses at all. This is the only one we're doing without glasses. And light is projected off a really special screen. It's really reflective, and it comes off at a acute angle specific to where the person is sitting. And at that point, he gets the 3D image, but it's really like only one person, so they never use it.
Okay, basically these are the type of glasses that you'll have when you go to watch a 3D movie at a movie theater. And the way it works is that when you have a pair of glasses, one side of the glasses is red, one side of the glasses is blue. That's because when you watch a 3D movie without the glasses, you'll see two images, and one of them has a red tint, the other one has a blue tint. And so when you put the glasses on, the red side will only let through the red tinted image, and the blue side will only let through the blue tinted image. The other type of glasses we have that you can use to watch a 3D movie are polarized glasses. And the way they work is that there's two images on the screen, and one of them is polarized so that they can only go through the right lens of your glasses, and the other one is polarized so that it can only go through the left lens of your glasses. And the reason it works is because this one only lets the horizontal waves of light go through, and this one only lets the vertical waves because of the way that the glasses are polarized. This is the main type of glasses that we're going to be focusing on for our project.
How does IMAX 3D work? Well, IMAX 3D is more of an illusion that your brain perceives while you're viewing the film. During filming, the camera that is used has two lenses that are used to, per se, mimic the human eye. And while it's filmed, two separate rolls are used during each filming for each lens. And while they're played back, they produce one single image. During projection, when you view it, the image is passed through two polarizers that are perpendicular to the image. What I mean is, your glasses are also polarized to the respective lens. Your right lens is polarized with the right projection lens, and your left lens is polarized to the left projection lens. So when you wear the glasses, the image that you see, your eyes are only seeing the image that are assigned to it. Your right eye is only seeing the right portion of the image, or the right lens of the image, and your left eye is only seeing the left lens of the image. And as you see that, your brain perceives that the image is 3D when it's really not, because it is displayed on a 2D screen.
So we all know that to make a 3D movie, you need to polarize the light. But how do you polarize light? Here to talk about it is Dr. Scott.
Okay, so usually what happens is that when we are trying to polarize light, we usually use what we call a Polaroid filter or a polarizing filter. And that's typically made of specially treated plastics. And these plastics tend to have very, very long chain molecules. Usually we kind of represent them by these kinks. And the important thing here is how we're going to align them. So we want to align the long chain molecules, usually in this first example, vertical. And the general rule is if the long chain molecules that in this specially treated plastic is aligned vertically, then we're going to have an axis of polarization, or polarization axis, that's going to be horizontal, meaning This special plastic is going to absorb light vibrating in all directions except that which is vertical. And so it means that our plane polarized light is going to come through and the light is only going to vibrate in this horizontal plane. Another option is if we actually align those molecules so that they're horizontal now, it means then that it's going to absorb light vibrating in all directions except that which is vertical to it. So it means that it's going to polarize light so that only the light that's vertical to the alignment of the molecule, meaning that this vertical axis is now going to be the polarization axis. That is going to be our new plane polarized light.
So now we know how 3D movies are filmed and how the light is polarized when it's played through the lenses, but we need to know how our eyes can interpret this 2D image to a 3D image. As Clay discussed a second ago, the two rolls of film are played through two separate projectors at the movie theater and onto one screen, and the images overlap slightly so that when you see it with the naked eye, it looks like one image with the edges blurred. When you put on the glasses, the image looks 3D suddenly and it pops out of the screen. This has to do with how the brain and the eyes see light. This diagram depicts an eye seeing a pear. The light from the pear travels to the eye and through the lens, where it is focused onto the back of the eye, called the retina. The indented portion of the retina is called the fovea, which is the point of greatest clarity in the eye. As you see, the image is inverted when it reaches the retina. The light is then converted to an electrical impulse and sent through the optic nerve to the occipital lobe of the brain. There, the image is neurally computed, flipping it right side up again. The image from one eye is interpreted by the brain to be 2D. So how does the world, and more specifically, how do 3D movies become 3D? This all has to do with how your brain perceives depth. At all times, both of your eyes are sending images to your brain, but these images aren't the same. One eye has a slightly different perspective than the other, and the brain puts these two images together to form one 3D image. This is called stereo vision. The same type of stereo vision happens while watching a movie through polarized glasses, with each eye only being able to see one of the two overlapping images. It tricks the brain into interpreting the image as 3D.
If you want something to play with, go and find yourself a toy. 'Cause baby, my time is too expensive, and I'm not a little boy. No.